All right, now we're going to start part 2 of the Salmonids et al. Video lecture. So we've gone through and we've done the subfamily Salmonidae. So we're moving on to Thymalinae and Coregoninae. Arctic grayling are Thymalus arcticus. They are both native and non-native in the state of Montana. They're a spring spawner. They have teeth on their jaws, which these teeth are important to determine whether or not it's a coregonid or a whitefish. They were once common throughout the upper Missouri drainage and are now native to the upper Big Hole River, Red Rocks Lake, and Red Rocks Lake. But they were introduced widely in high mountain lakes, for example, Highlight Reservoir. They are broadcast spawners over gravel, so they do not build reds like trout or salmon. Their body is round and elongate with a long adipose fin and large silvery. The subfamily grayling have teeth on their jaws while Coregoninae do not. They have a longer based dorsal fin with more than 17 rays, this compared to Salmonidae, and they have relatively large scales. The Arctic grayling has a very elongated dorsal fin and a deeply forked caudal fin. They do have sexual dimorphism in size and shape of their dorsal fin in adults. Mature male dorsal fins are especially large and colorful. They have very large scales compared to trout. And like I mentioned before, they are spring spawners and broadcast eggs over the substrate, so they don't build reds. Here's a great example of a nice big male. So we have this long dorsal fin, these very large scales, and they do have very few spots compared to trout, but you can see that they're not extending past the body and they're very concentrated on this midline.
It's been an ongoing debate for years whether the Endangered Species Act should protect Montana's river-dwelling Arctic grayling.
83.
But as this question is posed once again, the agencies and landowners who will be affected by the decision are surprisingly unconcerned.
The landowners are just as interested in doing projects now as they were 3 or 4 years ago. Even with the threat coming up, we saw people signing up to do projects.
For more than a decade, a coalition has been working together to improve grayling habitat in the upper Big Hole Valley.
What you have is you have the agencies, the non-government organizations that are stakeholders in the Big Hole, and then the private landowners all coming together with a similar goal, really, of just making the upper Big Hole a better place.
Today there are projects across the valley, and while the process is slow, this work is benefiting the grayling.
We've seen increase in numbers in areas where we've done restoration, where we've worked with the landowner to manage livestock and improve stream flows and make sure there's no barriers to migration.
13 even.
And while the listing status of Montana's grayling is still in question, one thing's for sure, this diverse coalition will continue to save the grayling. In one of Montana's most remote places, Montana State University researchers strap on skis and head out onto the ice to track Arctic grayling.
The more we know about this population in this lake and the habitats that are critical to their survival throughout the winter, the better we'll be able to manage grayling throughout the state.
This research is part of a broader look at one of the last strongholds of Arctic grayling in Montana.
Well, even though populations are presently doing fairly well, some of the highest abundances we've seen in 50 years, we want to make sure we understand what the population drivers are. So going forward, we're making the right management and conservation decisions to ensure long-term viability.
He's right here.
Along with monitoring the grayling's winter habitat, other factors biologists are looking at is the quality of spawning areas and whether other fish species are having an impact on grayling. Information that will go a long way in securing the future of Montana's Arctic grayling populations.
Well, this is just one piece of broader grayling conservation, and if we're able to show in most of the places there still are Montana Arctic grayling, that we've got good strategies and conservation measures on the ground, then there's less reason to list this species to ensure its long-term viability and persistence in Montana.
Winston Greeley. Out among Montana's fish.
So next we have the mountain whitefish, Prosopium williamsoni. They are native and a fall spawner, also a broadcast spawner. They completely lack teeth on their jaws. They're very widely distributed, but they are declining in some areas. Note that the specimens for Prosopium and Coregonus are not great and can be hard to distinguish the differences. You will be responsible for identifying mountain whitefish visually, but for the remaining 3 species, you'll only be responsible in identifying the differences between Prosopium and Coregonus, so the different genuses, and will not be responsible for identifying the pygmy whitefish, lake whitefish, or Cisco species. However, you will still be responsible for identifying their general distribution and whether they are native or non-native. Prosopium have a single flap between the 2 openings of each nostril, while Coregonus has 2 flaps. You should look at the illustration in Brown, 1971, page 41. Prosopium is more cylindrical and Coregonus is more laterally compressed. Along with suckers, the mountain whitefish are often the most abundant species present in large rivers and reservoirs, but their abundance seems to be noticeably declining in some large river systems throughout the West.
Monster, yeah.
Research is underway to learn about the apparent decline of Montana's mountain whitefish.
Well, the thing with whitefish is we don't know a lot about them, but we know a lot about their environments, the habitats that they use, and a lot of the related fish. So I think we can come to an understanding of whitefish, and a quick way to do that is to coordinate efforts that are going on in the north part of the state, the southwest part of the state, and the central part of the state.
One of these whitefish efforts is taking place on the Flathead River, where researchers are using radio transmitters to see if they can verify local angler reports of catching fewer whitefish.
It's important we try to figure out why that is, not just for the anglers who like to fish for them, because that is important, but also for the whole community of fish.
Whitefish have long had a bad name, but their importance to a river is one reason for people to reconsider these native fish.
Whitefish are a really important component of the river. Their presence benefits not only anglers, but other fish and other animals that use them.
The extent of Montana's whitefish decline is not yet known. However, fish managers do know what they learn about whitefish will have many benefits.
The whitefish generally has a larger anal fin than the trout, and they do have some dorsal spotting patterns in younger fish, which may make them difficult to distinguish from grayling. They have fewer dorsal fins than the grayling, and more smaller scales in the lateral line than the pygmy whitefish. Pygmy whitefish, Prosopium coulteri, are native to northwestern Montana and they're a species of concern. They're also a spring spawner and lack teeth on their jaws. They have a restricted distribution and a single flap between the nostrils on each side. Their overall appearance is very silvery or white, except for an olive brown back. The snout overhangs the mouth, the jaw lacks visible teeth, and like I mentioned, there's a single flap between the nostrils on each side. The eye is very large, which is about the same diameter as the snout length, and they have a transparent membrane surrounding the eye that has a distinct notch below the rear edge of the pupil. Here's an example of that notch.
Here we go.
When Russ Geldrich took his family ice fishing a few weeks ago, he had an idea that he would come back with a new state record.
And I said, well, let's go to the bottom and either catch a big salmon or shatter the pygmy whitefish record. So it was a lucky call, that's for sure.
What he didn't know was that his 10-inch and 1/3 of a pound fish would shatter the previous state record.
I can't believe they're making such a big deal out of that little dinky fish. It's amazing.
This little fish is a pygmy whitefish, found in only a handful of lakes across northwest Montana.
He's pretty big, actually.
Geldrich is one of 6 people who have set or broken the state record in the last 5 years.
Oh, look at that hog.
This is because a while back, the kokanee fishermen learned the bigger salmon were on the bottom of the lake. And coincidentally, that's where the pygmies live.
There's guys that are actually trying to get the record now. It's actually a pretty achievable goal. It's not like catching the state record pike, you know, where you got to go get a 36-pounder.
And as more anglers become aware of these unique native fish, Russ knows his record will soon be broken. But by whom? He can only.
Next we have the Cisco Coregonus artedi. They are non-native and were introduced from the Great Lakes into Fort Peck and Tiber reservoirs. The Cisco has a terminal mouth and long, fine, closely spaced gill rakers. They're strictly planktivorous. They are also a fall spawner.
Fort Peck Reservoir produces some big fish, from salmon to lake trout to walleyes. Fish biologists say the secret to these large fish are Cisco.
Looking particularly at walleye, the size structure changed, after Cisco had become established. We started seeing more fish over, say, 25 inches, close to 30 inches, and it really changed the dynamics of the fishery.
Cisco, also known as lake herring, were stocked in Fort Peck in 1984. Found only here and in Tiber Reservoir, this non-native plankton-eating fish is the equivalent of a double bacon cheeseburger to the popular game fish anglers seek.
Definitely providing a lot of nutrients out there for those bigger fish, and that's why we see 30-inch walleyes on an annual basis out here in Fort Peck, and big lake trout, big pike, and big salmon.
And even though the reservoir's Cisco population can be cyclical, the last 6 years has seen a Cisco boom.
In these last few years, we've seen good reproduction, but really we've seen, our pike, our walleye, lake trout, salmon, all those larger predatory species are, kind of at or above long-term averages. So they're eating them. And
Lake whitefish, Coregonus clupeiformis, are both native and non-native in Montana. They're native to Glacier National Park in the Saskatchewan drainage in Montana. They were introduced into Flathead Lake, where there's a small commercial fishery on them. They have a subterminal mouth, and they're more of a benthic feeder. They have coarser, more widely spaced gill rakers than Cisco, and they're also a fall spawner. So, rounding out the Salmonidae family, we have this great comparison of the common Salmonids that you could get confused. So these lecture slides will also be online, and I highly recommend studying this comparison in order to identify bull trout, brown trout, brook trout, and lake trout from each other. Once again, I would strongly recommend studying this figure. All right, so we're moving on to the et al. And others part of the Salmonids et al. Lecture. So we'll be going over Clupeidae, or herrings, Hyodontidae, or moon eyes, Osmeridae, smelts, Isocidae, pike, Umbridae, mud minnows, and Gattidae, cods. Clupeidae, or gizzard shad, Dorosima cepedianum, were introduced for sportfish prey in many places throughout the United States. They are temperature limited and they're plankton feeders. So think about what other small forage fish is a plankton feeder. We have kokanee, so they have very similar life history strategy to the kokanee, however, they are temperature limited. The species is not found in Montana yet, but likely will be in the future and has been introduced into some Wyoming reservoirs. Shad are a freshwater herring, and the herring family is a very commercially and ecologically important group in the ocean. They're an important prey item for many piscivores in both the Atlantic and Pacific Oceans. Shad, primarily gizzard shad, and threadfin, so they're called threadfin because of this long extended ray on their dorsal fin, are native to the southeastern U.S. but have been introduced widely in western states and in reservoirs as a prey species for sport fishes like walleye and bass. They are temperature limited, and temperatures below 10 degrees Celsius in the winter, they tend to die off and have been restocked annually. So right now their northern range is limited by low winter temperatures, but with anticipated warming, distribution is likely to shift northward. They are one of those double-edged sword species that become so prolific they can really boost predator populations, but as open water planktivores, they are also so efficient at filtering plankton that if they become too abundant, they can limit the important prey source of plankton for other species during their larval stages. So with that, you might initially get a burst of predator abundance when first introduced or when they're first invaded, but then later this boost will drop as predators don't have enough to eat during the critical larval stages. Next we have Hyodontidae, or goldeye, Hyodon allosoides. Goldeye are native and widely distributed in lower to mid Missouri and Yellowstone River basins. They have a very wide distribution in North America, from the lower Mississippi drainage northwestward to northern California. They have a very large reflective eye with a laterally compressed body. Their eyes are very large and positioned very far forward on their head, and have a mirror-like tapetum lucidum in their eyes. The tapetum lucidum is a reflective layer that enhances vision in low light conditions. This is also present in walleye and sauger, and an adaptation for seeing in low light or turbid conditions. So if we're thinking about the Missouri River and where this fish is native, right, these rivers aren't necessarily the cool, clear waters that we picture trout in, and that is why they have this tapetum lucidum. They do have a lateral line and very large teeth on their tongue and a large palatine bones in their mouth, which is pointed out here. They do not have a serrated keel compared to the clupeids or the gizzard shad. And they have semi-buoyant eggs that are laid in the spring and hatch in about 2 weeks. They frequently feed on the surface like trout. Their diet is very broad and includes insects and small fish. The anal fin on the males have a distinct fleshy lobe, and a great thing to compare the goldeye to the gizzard shad is their dorsal fin is set very, very far back on their body and is actually anterior to the front of their anal fin. Here's a nice picture showing the tapetum, a great picture showing the tapetum lucidum, this reflective layer of cells in their eye that helps reflect more light to allow them to see better in turbid or low light conditions. This is also present if you've ever taken a picture of your cat. That's that same structure. And this is simply a layer of guanine cells that's able to reflect more light. Next, the Osmeridae, rainbow smelt, Osmerix mordax. They are non-native to Montana and upriver from Lake Sakakawea in North Dakota. They're found in the Missouri River below Fort Peck and in some limited distributions in the lower Yellowstone River. They're a non-native species originally from the Great Lakes, but like gizzard shad have been introduced into reservoirs throughout the country as a prey species. Though they're primarily planktivorous, they have large mouths with teeth and also feed on small fish. In some reservoirs, they have caused problems as they can prey on small stages of game fish like walleye and bass and cause recruitment problems. Note the adipose fin in the rainbow smelt. But, right, they are not a salmonid, but they do have an adipose fin. So if we're getting confused comparing the rainbow smelt to the goldeye or the gizzard shad, rainbow smelt have an adipose fin. Next, we have family Isocidae, northern pike, Esox lucius. Northern pike are native to the Saskatchewan River drainage in Montana. They were introduced into Missouri and Columbia River drainages. They have a flattened, bill-like snout with numerous sharp teeth on their lower jaw, vomer and palatine bones on the roof of their mouth. They have very large sensory pores, which are part of the lateral line system, on the ventral surface of their lower jaw. So if we flip them over, you'll see these exaggerated pores on that lower jaw. The coloration is typically lighter bars and spots on darker, mottled greenish background. The bars are more pronounced in smaller individuals. They thrive in marshy, weedy lakes and backwaters. They broadcast adhesive eggs over flooded vegetation in spring soon after ice out. So I think a lot of you are familiar with the northern pike. Remember, we have this elongated body shape. This is the poster child for an explosive predator, right? An ambush predator. And they're both native and non-native in the state of Montana. Here's great examples of pure northern pike. Then we have a northern pike and muskie hybrid, also known as a tiger muskie. Note that muskie are not found in Montana. However, tiger muskie is that hybrid between muskie and pike, and they have been introduced in a few water bodies for prey fish control purposes. These hybrids are sterile, though not all hybrids of other fish species are, so their numbers can be controlled by stocking and harvest rates. The tiger muskie has greenish vertical bars on a very light background. Next we have the family Umbridae or mud minnows, the central mud minnow, Umbra limi. Though they're much smaller in size than saucids, mud minnows share the same body shape and mouth structure as a saucidae, or the pike. Mud minnows are distributed in North America and Asia. They were introduced and have recently become established in Blacktail Creek in Butte as a result of an unauthorized introduction. They're now recorded in several other locales in western Montana. The natural range of central mud minnow is now in the north-central U.S. in south of the Great Lakes. They have a rounded caudal fin with very dark vertical bars at the base of their caudal fin. Their premaxillary is not protractile, and they don't have an upturned mouth as plains killifish do. And like pike, they have single dorsal fin that lacks spines and is placed well back on the body. Darters and Percidae have two dorsal fins. The first dorsal fin is spiny. So here's an example of the central mud minnow, and we have the plains killifish and a sculpin as comparisons of fish that you may end up mixing up as we get on later in lecture. We remember the central mud minnow and the plains killifish are dissimilar because the plains killifish has this upturned mouth and also more of this triangular head shape, while the central mud minnow overall is more rounded. And then when we compare the central mud minnow to the sculpin not only have two dorsal fins, but their pelvic fins are also more in a thoracic position. So finally, we have family Gattidae, or cods. Gattidae, or true cod family, constitute one of the most numerous fish species on Earth. Members of this group are primarily marine, representing many commercially important species, such as Atlantic cod, haddock, and pollock. Burbot, or Lota, also known as ling, lawyer, eel pout, and freshwater cod, are native and widely distributed in Montana. They're unusual in that it occurs in all three major drainages in Montana. Their native range is circumpolar, mostly cold, deep lakes and rivers. They have this very eel-like shape and a single median chin barbel, which is extremely unusual for any of the fishes that we have in Montana. They have a deep notch that separates the first and second dorsal fins. And they have this very elongated anal fin. They support an important winter ice fishery in Montana reservoirs. There's been a recent upsurge in interest in the status of the species throughout its range due to greater angling popularity and apparently declining numbers. When very small, they can look like sculpin, but the first dorsal fin on burbot is smaller, their snout is less blunt, and their eyes are set further back than sculpin. And then finally, sculpin do not have any chin barbels, and they have very, very large pectoral fins. Burbot are piscivorous as adults, and they spawn in winter under the ice in writhing balls at night.
Many refer to the 1970s and 80s as the glory days for burbot fishing on the Yellowstone River.
There's some ling in there.
But today, fish biologists hope monitoring efforts will revive the burbot fishery near Montana's largest city.
Is this the same fishery that we had in the 1970s and 1980s? Probably not, because we don't have people that are taking home bucket loads of fish, but we have heard that people seem to be catching a few more fish than what they used to.
The burbot is unlike any other fish in the world. Also known as ling, it is the only freshwater member of the cod family. A popular game fish, sought for the dinner table, it's also a native fish biologists want to know more about.
We didn't really have much information on the fishery itself, not size structure, not kind of any relative abundance. So this is aiming to really take a good look at the population to see where we're at and make some decisions based on that.
2.40.
Some of these decisions may include habitat work and regulation changes, but the main goal of these ling efforts is to create a better fishery for Montanans.
I think if we had a better ling fishery, that's going to expand opportunities for people to be out on the river earlier and later during the winter, with the idea that they're actually going to catch something here on the river.
Here's some great examples of burbot pictures. I think they're one of the cutest fish. You should note the mottled coloration, their snake-like body. And when they're small, right, we could possibly mistake this for a sculpin, but we're not going to because we know it has a single median chin barbel, and their pectoral fins aren't very large. So that is it for the Salmonids et al. Lectures. Thank you for hanging on with me. Your quiz is due on Friday, February 21st at 11 p.m. on D2L. Next week, on February 24th and February 25th, you're going to work through keying out fishes in lab. You'll have a handout to complete to key out all fish, and that handout will be graded. Also, we'll start minnows on March 2nd and March 3rd, and then we'll have 2 class periods for minnows. Minnows are very difficult, so you should definitely come in on the 24th and the 25th and practice using the Montana Fishes app in that open lab to get yourself familiar with keying out fish. All right, thank you so much for listening, and please feel free to email me if you have any questions or concerns.